Accion Lab Innovation Summit 2019.
Good morning, everyone. This time we move to decentralized apps and how blockchain leads to revolutionary new types of applications. And to that end, we are very pleased to welcome Shaheed Sheikh, technology lead and an author and blogger who brings over 5 years of experience in solving critical problems in these mission-critical areas of blockchain and decentralized applications. So please give him a warm welcome.
Before we actually go ahead with the decentralized application, let's have a quick recap, because in the last year summit also, Ash has a very good presentation on blockchain and basics of it. So last year we have discussed about the basics of blockchain, the types of blockchain, how it works, and which industries can be used. And we have also seen the demo on multi-chain, such as public, federated, and private. And we saw the private demonstration on multi-chain. So before we go start, the majority of the credit of blockchain actually goes to the Bitcoin, right? The invention of Bitcoin by Satoshi in 2009 has led to the revolution in fintech, or especially in the transactional area. And surprisingly, in the last summit, the Bitcoin was at its peak. Last March, Bitcoin was about $20,000. Due to the popularity of the Bitcoin and the way it works in immutable decentralized ledger, the majority, like technicians or scientists, they have figured out a way to take the best part out of it, such as blockchain, and applied it to various aspects. But the thing is, the blockchain, the term may be the new, but the technology which is running the blockchain, like the decentralization or the cryptography or the Merkle trees, they are not actually that new. They are very old. So in the 90s, those concepts were already there. The Merkle tree, the distributed applications, the decentralization, the very important one is asymmetric cryptographies as well. But what Satoshi did actually in 2009 is he has combined multiple technologies together to solve one simple problem. Problem was to remove the third-party trust issues by using immutable store of ledger spread across multiple pairs around the world. That thing is actually designed was only for transactional storage. And transactional things took over around 2011 to 2012 when majority of the Bitcoins were stored on the blockchain. But then Vladimir has invented Ethereum. So other than just using blockchain for transactions, you can write a code and execute on it. It is actually called smart contracts. Those contracts can help you to write decisions, which will be executed on top of blockchain based on various conditions. For example, an escrow, right? So a middle party who is actually facilitating a service and payment between two parties can be actually programmed and deployed on Ethereum. That third-party trust will be removed, and peer-to-peer can actually make sure that if one has provided a service, Ethereum or the money will be transferred from the service provider account to the one who has actually worked. Well, the contracts actually revolutionized the way we think about the blockchain. Initially, it was all about storing transactions or disrupting the financial industry or creating cryptocurrencies for various countries or various things. Well, smart contracts gives wave of new kind of applications. You can run your app on a decentralized network running on top of your existing internet. And that is possible now. And that new thing is what we are terminalizing as decentralized applications, which is either running on permissioned blockchain or either running on public blockchain. But this application is the new feature which is running on top of blockchain. And so this was a bit of history. Before we go ahead of the decentralization, I just want to give a small demo on how smart contracts actually work. So this is a bit of sample application architect. So if you want to be part of the Ethereum network, or any Bitcoin network, basically, you need to become a peer. So you become a peer, join the network, synchronize all the data of the network, and that is the part of Ethereum P2P network. Then you can write your code, which will be Ethereum code in a Solidity programming language. Your code will be deployed on Ethereum blockchain. That can be invoked using web3.js, which is also Ethereum's library. So let's look over one small demo. Like I gave you the escrow example, I made a small demo. So this is the screen to any freelancer who can actually request an invoice to any person. Basically, this is just a simple form where you can give the details and everything to whom he wants to send. All the product details, and the rate and the price we are actually calculating in Ethereum. So suppose he has done some service and he wants to be paid in form of Ethereum, 100 Ethereum. So he can send an invoice, and this invoice will be recorded in blockchain. So he'll be given a transaction hash. This is the hash which is given on every contract execution. So either your contract is like adding an invoice or either doing any task basically in blockchain, you can consider it is recorded and you have a hash. Whatever you do, whatever your action is, it is recorded and you get a hash as a response. And this you can actually verify. This is the small tool which we run in our local machine called Kenachi. So in that, if you just paste your transaction hash, you can see that it is already added into the network. In practical scenario, this will be added and mined into the blockchain network so that it can't be altered at all. The guy at the company level cannot say that they haven't received the invoice because it is recorded into the blockchain. So the trust factor has been removed at that part. Then comes the company area, right? Over here, company received the invoice and he can again verify the hash because he also gets the hash of the customer. And then if he approves, he also gets a hash for that yeah, he has approved and the money has been transferred. So that even the freelancers can say that I haven't received the money because it's also recorded in the blockchain network. Once you go to the client screen, if you see, here's the balance has been increased. If you see the companies, the balance is deducted. This all happened without having any third party to basically facilitate the payment. It's all peer-to-peer. Public blockchain is great, but the openness of the network and the anonymity of the peers do not basically match up with the organizations and the companies. Majority of the organization actually wants to leverage the blockchain feature, but within their own permission network. And then enters the federated or permission blockchain. And one of the most popular projects are the Hyperledger. You can consider Hyperledger as is ecosystem of the blockchain network. They don't just provide Hyperledger Fabric, they have Hyperledger Indy, Hyperledger Quill for different scenarios of, for example, if someone wants to have a private and permission supply chain blockchain system, they can directly use Hyperledger Quill to build that. If they want to have an identity-based blockchain system, they can use Hyperledger, Quill to do that. In Hyperledger Fabric, this is a basic blockchain network on which you can execute the contracts. And the way it works is if you all know, the way consensus has been done in public blockchain network is by doing the mining. So the way it works is whenever someone wants to add a block into the network, they have to prove that they have actually worked for it. And the way Bitcoin does that, or the way any public blockchain does that, give you the difficulty number, which is in hexadecimal. They also give you the target number. All you have to do is basically calculate a hash which has that number of zeros in front of it. Now it seems similar, but calculating random hash is actually very CPU intensive task. And that takes lot of energy in order to basically compute a hash, which matches the difficulty number. But in case of permission blockchain, you don't need to do that at all, because all of your node and peers joined only with your permission, and they have been assigned a certificate authority. So in case of Hyperledger as well, we have endorser peer, anchor peer, and normal general peer. If we take this example at Accion Labs Mumbai, the company A, and company B would be Accion Labs Bangalore or the US one, the ordering peer is the one which communicates between the two permission blockchain network. So if client apps wants to add something into the blockchain, they first contact to endorser peer. The endorser peer job is to actually validate whether the client is correct or not by verifying the certificate authority. That's pretty much it. Then the client app actually contact the ordering peer. An ordering peer actually does the entry into the blockchain. And ordering peer again then contacts the anchor peers of each network, which actually in turn is going to update each of the blockchain network. And all the peers will get basically synced up and the consensus happen. This kind of application, especially the private blockchain network, is very suitable for very sensitive sort of data. We have discussed yesterday too the hospital data, right? The patient information or identity information, putting them in a public blockchain is actually a bit not standardized way. So the way it works is you can put all those information in your private Hyperledger network. So I have one demo on Hyperledger as well. I'm going to just play the demo. So here is a very simple app where one can log in and add the patient information. So these are already added. You just click on, give them some ID, name, the payment details, the patient medical information, all those sensitive data which you want to store. And it will get first added into the Hyperledger and then any middle layer databases to just have a cross references between ID and the blockchain hash. And this entry, then you can verify in your Hyperledger network. Basically, they provide all the development suite you need in order to develop an app, either on Hyperledger Fabric or you want to facilitate an in-middle technology as well. The information is added into the blockchain network, and then you can basically add that information back to whichever database you want to have, just for the cross-referencing. Companies such as Amazon, IBM, and Infura, Azure, they are actually giving a service. They are running the blockchain as a peer, and you can participate by paying a small fee. So all you have to do is run your smart contract into there and focus your, give your focus on the business logic rather than just maintaining all the peers into the network. And some of these providers are AWS, Azure, Google as well, and IBM, Oracle, SAP, Ethereum, Quorum. Quorum is one of the blockchain network being facilitated by Deloitte, I believe, and also by JP Morgan. The Hyperledger one, the Digital Assets, and CRDA. Majority, and I think the Hyperledger one, you can also use as a public one, as a private one. It depends on your configuration. While Ethereum and Quorum, they are public blockchain network right now. So let's look at some of the industries that blockchain is either disrupting or will be disrupting. This is actually divided into 4 sections: the currency, record keeping, securities, and smart contracts. We all know about the currencies. It's nothing new. Blockchain has already is disrupting the complete financial sector by putting all the transaction record in distributed ledger. While coming on report keeping, like intellectual property or ownership, like Pamela gave the introduction on the Borseta platform, the tracking of the objects from its source to the current owner. And if you record each of these steps in the supply chain network or in the blockchain network, for example, the Borseta said, if you have a chip on your phone and you're going to buy the phone, you just scan the chip and you get to know from where it actually belongs because it is written into the blockchain network. That thing will completely basically revolutionize the counterfeit operation, as Pamela has mentioned. Also in the securities, if you put equity information, house details, or property information, and all those sensitive information which actually comes to these trust-based issues can be put over the blockchain. And the smart contracts, scrolls, wagers, and digital rights, of course. But the area which actually coming up and being developed in under development is the decentralized application. Like I gave you the Silicon Valley example, right? In that episode, the Richard actually tries to develop an peer-to-peer internet where there is no central server, there is no central point of failure, everything is peer. And the data shared by the humans belongs to them. And they have the complete control over it, whether they want it to share to the particular peer or not. And is that possible or not? That was a debate of the past, I can say. Now it's being happening. And the blockchain actually gave that inspiration. And let me tell you how. I mean, the World Wide Web right now is completely like centralized. You have server, you have client, and you have multiple data centers and everything. But the centralized nature of the World Wide Web and internet right now has given a lot of issues on basically central point of failure, stealing of data, intrusion, any sort of like government risks or anything. But if we say internet becomes public and public participate into and become a peer rather than trusting one person as who will host the central server, then that thing will actually revolutionize and make a new internet, which we are referring as Web 3.0. Let me tell you, this is already happening. If you consider Ethereum, for example, as I said, blockchain is good to just store transactional data because it's actually in KBs. All you have to store is from address, a true address, bit of metadata, and the amount, hash it together, and put it into the chain. But when it comes to storing files, such as videos, any sort of data on blockchain, Ethereum won't work. So Ethereum has a project called Swarm, which is like a file storage on decentralized network, communicating together with the Ethereum to make sure that every entry is recorded. And they have a project called Whisper, which is like, you can say, an event queue between decentralized applications. Because in order to develop an application, even from the developer's point of view, I will say, you will need database, you will need event queues, and you need to have a protocol on which you can communicate to other peers. And this is the Ethereum project, but you can say the only drawback is you have to be on the Ethereum in order to use this tool. And then comes the open decentralized applications. And the most popular one is from the protocol.ai. The protocol.ai is basically dedicated to make decentralized version of internet. And their stack is this. Consider like a TCP/IP stack, application layer, networking layer, data layer, right? And networking layer right now is huge. I mean, and we can say that, okay, let's come up with a new networking network and let everyone replace it. So the way IPFS is, they are building a protocol which is going to run on top of existing protocols such as TCP/IP, UDP, WebRTC, so that not every mass user have to basically update their browser or everything else. The libp2p is the peer-to-peer library to make sure that peers are recognized, identified, they are connected together, named together, and you are sharing your data in complete end-to-end encryption format using asymmetric cryptography used in blockchain. And there comes a naming service. It is interplanetary naming service, by the way. The way we use DNS to basically name our nodes and route the traffic from the one node to another in decentralized manner. IPNS and IPLD is the project which is going to help you in order to do that. And then comes the layer which is the IPFS stack, the development layer, right? So these two layers, libp2p and IPNS, these are, you can say, a networking layer. When it comes to developing a decentralized app, you have projects such as IPFS, which is interplanetary file system. So you can run your, like these two computers right now are IPFS peer. And you can run your master server in your machine and share the file across your peer. Once you add the file, you get the hash. You share that hash with anyone, they are easily going to access that. You have multiple peers connected across the world. You can share your files and ask anyone in the world to access that file without using any centralized server. It's all peer-to-peer, running on top of existing internet technologies, using IPFS stack. At IPFS, there was also a very interesting project going on in the web, which is called Stream. Stream was the first one to actually solve the problem of putting metadata information on blockchain. So if you see, this looks like Reddit, right? So you can ask questions, you can upvote, comment, and everything, and this is completely decentralized. The Stream blockchain allows you to put your metadata information in blockchain. And the very interesting feature is it gets you paid. So whoever is part of the network, and if they are doing good, Stream actually rewards them using Stream coin, which you can then go to the exchanges like Binance and convert into dollars. And the same idea has been taken to the next screenshot I'm showing you. This is called D.Tube. It's a decentralized version of YouTube. Currently working on IPFS, but this is not a client-server base. This is completely peer-to-peer. And people who are participating in this are actually getting paid not by advertisers, but by the system itself. And that is a very good example. So if I play any video, and if he gets a lot of views, you can see he's getting paid. So this is really a great example that decentralization application is not things of past. And this is one of the examples that I'm giving you. There are, I'm sure, a lot of examples on internet where people are actually contributing and developing on top of IPFS stack or Ethereum stack to develop new type of application for the next generation of the web. And before I sum up, I'm going to give you one small demo on IPFS. So, like I said, these two machines are IPFS peers. One of the project which is going on, it is also open source, is called OrbitDB, which is like MongoDB for decentralized apps running on top of IPFS. Any developer can use that, add their entries into the database, which will get replicated across the peers. So this is a very simple to-do app. The way I did the configuration is that, so if I make an entry over there, I should get over here as well, without any centralized server synchronization. So let me make a small entry here. Entry is added, and it is added to the IPFS. This synchronization happens without any centralization server. And if I make any changes in this node, which is also IPFS node, like for example, if I check this node, I should get it here as well. And there you go. I just want to conclude my talk saying the decentralized web, I believe that it is going to be the future of internet. And this thing is already happening.
Accion Lab Innovation Summit 2019.